This tutorial explores scheduling and DOM components within Odoo. For this example, we will focus on a manufactured product and its journey through production scheduling and material procurement. First, we examine the bill of materials for IoT 123, a product comprised of 3 raw materials: printed plastic, wipes, and microcontrollers, all supplied by ForgeFlow. This product is buffered, necessitating a calculation of the buffer's coupling time, which considers the longest path, in this case, the microcontroller leg, with a purchase lead time of 10 days, plus 1 day for manufacturing. The buffer's net flow position appears in yellow, indicating a need for reordering. We will procure the buffer respecting the batches, which will initiate manufacturing orders to maintain the buffer status in green. Transitioning to the manufacturing side, the addition of new orders from recent procurement reveals a lack of available components for most manufacturing orders. Before scheduling work orders, completing the planning phase is essential. Since the components are unbuffered, we will use MRP to address this, bypassing detailed discussion for brevity. The outcome of procuring the components is a fully prepared purchase order, which we will now receive to ensure we have component availability. With components now available, we revisit the manufacturing orders to reserve material for each. The process involves scheduling a start date for each work order, encompassing 3 steps for our product: printing the plastic frame, removing the support material, and assembling with the glass and microcontroller. Attention then shifts to control points, essential for monitoring production flow. For demonstration, 2 control points are set in the initial work centers, identifying the first operation at printed station 1 as the drum, the scheduling bottleneck. We will focus on scheduling from the drum and then sync the other operations with it. A time buffer profile of 12 hours is applied, incorporating the DDMRP time buffer to evaluate work center timing against scheduled dates. Conditions requiring a reason code before starting work are established to maintain time buffer integrity. In this example, we will just need an explanation when the stage is late. Control points configuration concludes with setting reason codes, such as materials not available and work center maintenance, for operational clarity and troubleshooting. In our control point overview, we can see what's pending to be received. Here we see that we are waiting for components for all our work orders. The orders that are marked as early don't have a scheduled start. They are not planned, so the system assumes they are early. Some work orders already have a scheduled start. Depending on the schedule, the system categorizes them. They are at different points in the time buffer. When checking the second control point, which corresponds to the second work order, we can see they are all waiting for the previous work order, and they have yet to be received. Nothing has been received at any of the control points. Let's go back to the manufacturing orders, and now we can do 2 things. We can plan, so now all our work orders will have a date, and we can also see the planning, for example, by work center. The code corresponds to the work orders of the same MO. So for example, we see here this MO. This is the first work order, second work order, and the last work order in the electronic assembly station. We are able to change the work order, and then with that, since this is the work order in the drum, we see how the subsequent work orders move to align with the drum schedule. What else we can see now? In the overview of the work centers, we can see the capacity that is planned for the different work centers. Since we set our printing station as drum because it's the bottleneck, we tried to plan it to be as full as possible, and we see that our capacity is 100%. We can also see that this week we are over capacity because of some wrong planning. You can also change the scheduled date on the manufacturing orders, and as soon as you save, all the other work orders will align using the working days and the working hours, which you can set up in the work center. Now we are ready to check availability to reserve the components to start the manufacturing order. If we do that for the manufacturing order 30, and we go to our control point, we see that we have already received this operation. We are early, so we could click on the operation and produce it, and mark as done. Now, the screen is empty again, and nothing has been received. If I had something else to process, it would show here. We have processed the first operation, and in the second control point, we now see that we have received the component. The first operation has been processed, and we can now process the second. Since we are in the red of the time buffer, and during the configuration, we selected the option to require the code when the operation starts in red, so we are being asked for a reason code. I will provide the reason code for when materials are not available. Once the code has been provided, I can process the work order. That's the basics of the dynamics for the control points. To finish that work order, we can go to the last work center, which doesn't have control points, and works with the standard view, and process the last part of the manufacturing work order here. This will close the manufacturing order 30. Going back to the manufacturing order, we can see that it is done. It has recorded the original schedule date and the date when it was finally completed, as well as the start and end dates. Just to wrap up, we can explore some interesting reports. For instance, we can review the capacity load for the various work centers. By default, we can analyze the data from the last month, but since I don't have that data, I might need to choose a timeframe from yesterday to the end of June. With this information, we can generate a capacity report of the different work centers with a percentage of the capacity. We also have a report of the outlier events at the control point, for which we had to register reason codes. In the support control point work order analysis, we can see our time buffer, whether we receive items late or early, and when we start our operations for each station or control point. This is shown in blue and orange in the example. These are the basics, and I hope this tutorial has been insightful. Thank you for your attention.